welcome to CEC lectures. Myself Dr. Preeti Jagwani, Associate Professor, Department of Computer Science, Arabat College, University of Delhi. So in the previous lecture we were talking about how to create threads under this topic of multi-threading, and we have kind of named two particular ways. One is to extend the thread class and another one is to implement the interface runnable, and then we have started with the concept of the main thread. So main thread is something when a Java program starts up, one thread which will begin running immediately and automatically, that is the main thread, and this is the thread that is executed when the program begins. Now what is the importance of this thread? We have seen two, that is, this is the thread from which other child threads can be spawned, can be created, and another one, it is going to be the last thread to finish the execution or to get exit, because it performed the various shutdown actions. And as I have told you that it will be created automatically when the program starts. So now the question which was addressed in the last lecture was, can it be controlled? Yes, we can say that even if it is created automatically, it can be controlled through a thread object, and in order to have this thread object, we need to obtain a reference to this object by calling the method named as current thread. Now this current thread or this method current thread is a public and static member of the class thread, and its general form is shown here, that is static thread current thread. So now static, as I have told you, it is the public and the static member, then thread is the name of the class and the current thread is the name of the method. So here is the general form of this particular method. Now what is this method going to do? This method will return a reference to the thread inside which it is called. So for example, I am calling this function, or sorry, this method inside let us say main thread or inside any of the child's threads, then this method will return a reference to the thread in which it is called, or we can say this method will return a reference to the thread inside which it is calls. Now once you have a reference to that particular thread, which is kind of, let us say, main thread here, you can control it just like any other thread. So once we have a reference to the thread, that thread can be controlled just like any other thread. So it could be main thread, or it could be any other child thread. So when we were like trying to address that, how are we going to create or how are we going to control this main thread, that is through this thread object. We will be obtaining a reference to this to that thread object, and that reference can be obtained with the help of the method current thread, and by then calling various functions through that particular reference will help us in controlling that particular thread, which is actually the main thread. Now let us try to see a program for this particular task, where we have a main thread, as we we also had that main thread in our all previous programs, but we have not used that. So here we are going to use it. So we have named a class which is named as, let us say, current thread demo, and inside the main function, which is public static void main and string args, you all understand this whole line. So here we have thread t is equals to thread dot current thread. Now what does it mean? So this essentially means here we are going to obtain a reference, and that reference is actually will be stored inside this variable which is named as t, and this is a reference to the to the class thread or to the object of the class thread, and here we have it as thread t is equals to thread dot current thread. And then we need to print this current thread, and please remember that looking at this kind of screen, we can say this is a static method which is going to return a reference to the thread inside which it is called. So, here we are calling this method which is current thread inside the method main or inside the thread main. That means inside the T, the reference to the main thread will be stored, because main thread is presently the current thread. Now we are going to print that current thread, the reference of the current thread as T. And now as we have obtained the reference, I told you that after obtaining the reference, we can control the various functionalities, or we can control the implementation behavior manner by using the messages, by using the methods which are available inside the that class. So, here we have T dot set name my thread. So, that means we have kind of change the name of the current thread, which is the main thread, from main thread to now the new name is my thread. And for this we have used a function, we have used a method which is known as set name, and this set name is being called with the reference of the current thread. So, now that reference of the current thread, we have that in hand, which is named as T here, and then T dot set name my thread. And then after the name change, we are going to print that T again. So, before the name change, what was the name of that current thread which is being stored in, whose reference is being stored inside T, and then by after using T dot set name, we are going to look it into the name again. Now, another thing which we are going to do within this program is to kind of, we can say, play around with this thread. So, here we have a try catch, we can say, block. So, we have try, and within that try we have some functionality which we are going to use, and that is the functionality from the class thread, and that may kind of throw interrupted exceptions if your thread is being interrupted. So, that exception is also to be kind of handled properly. That is why we have used a try catch block here, and within the try we have kind of taken a loop for n is equals to 5 to n greater than 0, and every time it is kind of decrementing the value of n. So, that value is being decremented and the thread will go to sleep for 1000 milliseconds. So, every time for n is equals to 5 it is printed, thread will go to the sleep, then for n is equals to 4 the value print, and again it will go to the sleep. So, basically what are we trying to do here? We are actually trying to look into the concept or look into the functionality of the method sleep, which is a static method of this class thread, and that is why it has not been kind of called with any of the reference, with any of the objects. We are directly calling it along with the class name. So, that is why thread dot sleep, and this thread dot sleep is actually having two versions. One in one of the versions, a particular time slot in milliseconds is to be passed as an argument. Here we have taken that particular we can say version in which we are saying thread dot sleep for 1000 milliseconds, and if we are not going to use this thread, that means we will be using thread dot sleep with the empty parenthesis. So, that is the another version. We will be covering that version, I mean why that is being used. So, here what is happening, the kind of value of n is being printed, then the main thread will sleep for some time. That means it will kind of it will enter in an inactive state. So, thread dot sleep for let us say 1000 milliseconds, and this will go on for kind of 5 times, where for n is equals to 5 to n greater than 0. So, this is going to happen, and as I have told you that this code is actually enclosed inside a try block. Because of this, sleep may kind of throw an interrupted exception in case your thread is being interrupted by any of the by whatever reason. So we need to catch that interrupted exception E, and we need to provide a clean exit to the program, and then we will say within that catch block we will say system.out.println main thread interrupt, because then only it will kind of enter into inside the catch block, and then we have kind of finished our class, and we have kind of ended our main method also. So what we did, let us have a quick recap. So here we want to control the main thread, and in order to control the main thread inside the main function or inside the main thread, we can say we have obtained the reference by calling the function current thread, and then we have changed the name of the thread, and then we have we have experimented with a loop which is kind of printing the value from n is equals to 5 to n is equals to 1, and with every iteration of the loop it is sleeping for some 1000 milliseconds. So what is going to be the output of this particular program? So first of all, the original name of the current thread by the virtue of system.out.println current thread T will be kind of printed. Then the new name which we have set which is my thread will be printed, and then the 5 then these numbers from n is equals to 5 to n is equals to 1, and in between kind of printing these numbers, the thread will sleep every time for 1000 milliseconds. But trust me, it is such a kind of a small quantum of time that as an end user we will not be able to realize that thread is actually sleeping. You will say, or you will find that it seems that all the numbers 5, 4, 3, 2, 1 are kind of printed almost kind of one after another without any break in between. Now why I am saying without any break in between, it seems as if this is happening because this time quantum which we have supplied inside dot sleep is actually very small. So let us see, let us have a look at the output. So current thread is the thread, and then there is kind of main. After name change, the thread is my thread, and then we have 5, 4, 3, 2, 1, and ideally a gap must be observed between this 5, 4 between printing of this 5, 4, 3, 2, 1, but the in threading it depends many things or your output actually depends on your specific execution environment. So here you may not have any of the we can say gap in between. So if you want to actually observe the gap, you can kind of increase the time quantum which is given here as 1000. You can make it maybe 1 lakh or something like that. So then you will be able to kind of see you will be able to observe that 5 is being printed, then maybe for 1 second it is kind of stopping, then 4 is being printed, then after 1 second the 3 is being printed, and so on and so forth. So the earlier name of the thread is being displayed here on the screen, then after name change whatever the new thread is, that name that thread is now my thread, the name has been changed, that has been displayed, and then 5, 4, 3, 2, 1. So this is what what we did in this program. We have experimented with the thread main. We have kind of we can say observed, we have captured the reference of this main thread inside inside a variable which is the reference variable for the class thread, and that variable is nothing but T here, and then kind of we have experimented with this. So basic agenda behind this particular program is to show that how despite of this main thread being an automatic thread which is being created by the system, we have not created it, it is being created by the system, but yes we can kind of control many things about this particular thread. Now coming to this was actually the thread which was already created, and we have just obtained the reference and controlled it. We have tried to we can say experiment with some of the methods onto it. Now, what will happen if we actually want to create a thread from our by our own. So, the two ways which are there in order to create a thread, which I have also kind of told you earlier, which we have named earlier, is to implement the runnable interface, and another one is to extend the thread class. And yes, we will be looking into both of these ways by having some program. So, first of all, let us have a look with the first idea, or let us create a thread with the first idea, which is implementing the runnable interface. And trust me, it is the easiest way to create a thread. And what do we need to do here? We need to create a class. That class will implement the interface runnable. So, here this runnable actually abstracts a unit of executable code. A unit of executable code is there, which is being abstract under this wrapper runnable, and one can construct a thread on any of the object that implements runnable, or more specifically we can say one can construct a thread on any of the object of the class who is implementing runnable. Now, please recall the concept of interface implementation. We need to kind of supply body to some methods whose signatures are given in runnable. So, whose signatures are given inside an interface. So, for example, a particular class which is implementing an interface, then it is the responsibility of the class to provide the body to the methods which are declared inside that interface. So, in order to implement the runnable interface, a class needs to implement only a single method, and that method is nothing but run. What is the kind of we can say syntax of the run? That this is a public method, and the function is not accepting any of the kind of we can say as of now we are taking this version that this is not taking any of the parameters and neither returning anything. So, that means the syntax or the declaration of this run function is public void run. And now, within this run, so for example, we have implemented runnable, and now we need to provide the body to this function run, and inside this run the code that constitutes the new thread that will be given or that will be defined. So, that means this is the main function which is to be kind of we can say implemented by the class who is implementing the runnable interface, and within this method run, inside this run the code that constitutes the new thread will be defined. Now, actually how this is going to happen, that we will be that we will be seeing with the help of programs a program. But before going into that, let me mention some points about this run, that this run can call other methods, it can use other classes, it can declare variables, it can do all the functionalities just like the main thread can. Now, if it is kind of we can say just like the main thread, that means is there any difference between the main thread and the thread which is going to be created using this run, or is there any difference between the two methods? Yes, the difference is that run established the entry point for the other concurrent thread within the execution of the program, while the main is actually the entry point of the thread main thread, and the thread which is being kind of we can say which is being started with the method run will end before the main thread. So, that means as I have told you earlier, that main thread is going to be the last thread to exit from the program. So, that is the difference. The thread which is being created by run will end first, and the thread which is the main thread created by the method main will exit the program at the last. Now let us see how we are going to implement this particular interface, and then how we are going to use this. So let us see that with the help of a program. So here we have a class new thread, and the way which we have which we are exploring is to implement the interface runnable, and the syntax for this goes like class new thread implements runnable, and here we have taken an a variable of the class thread, and that variable is t, and inside the function new thread. So, we have started a function, we have defined a function new thread. So, as the name indicates, we are going to create a new thread, a new second thread. Why are we calling it as a second thread? Because the first thread will be the main thread itself, and here we are going to call a constructor of the class thread, and by writing t is equals to new thread this demo thread. So, this is actually we can say it is a pointer to the current thread, and demo thread will be the name, and this is what the syntax of the function this is what the syntax of the constructor thread is. So, thread here is actually a constructor. So, t is equals to new thread this demo thread, and then we will be printing t by giving it a label child thread, and we will be starting this thread by calling t dot start. So, while creating the new thread, what we did is we have created one class new thread which is going to implement the runnable. So, there are two ways, either it will implement the runnable or it will extend the class thread. So, here we are implementing runnable. We have taken one variable of the class thread, and inside the function new thread we are going to create a new thread which is having the reference to this current thread by the virtue of this keyword this, the name of which is going to be the demo thread, and we will be printing the name or printing the reference to that thread, and then we will start the thread by calling t dot start. Now, we have created it, we have tried to start it, but what is going to be, how it is going to enter inside the system, though that is the entry point for the second thread, and entry point for each and every thread is going to be through the method run, and the syntax for method run I have already told you, which is public void run, and then again the similar try catch block which you have used in our previous program. So, in the previous program we have used this loop to print 5 numbers and make the thread sleep for 1000 milliseconds, and which thread I am talking about here. In the previous program we have made our main thread sleep for some particular time instance. Here we are experimenting with the new thread which we have just created. So, inside this try within this for loop, so we have for integer I is equals to 5, I greater than 0, I minus minus. We need to print this counter value of this counter I, and then the thread will go on for sleeping 500 milliseconds. So, which thread I am talking about? The current thread obviously, which is the thread our child thread, the second thread I am talking about. This is not the main thread here, because sleep will be invoked, or sleep will make the thread sleep, which is actually the current thread. So, it is the method sleep who will actually we can say stops the execution for some time quantum, for a very small time, as we have given 500 milliseconds or 1000 milliseconds for the current thread. So, sleep will operate on the current thread, that is what the bottom line I am trying to say here. And then we have this catch because the this thread dot sleep may kind of may throw a particular interrupted exception. So, that has to be handled properly, and while coming out of this thread, we have return system.out.println exiting the child thread. Now, one thing here in this particular class, which is the class new thread, which is implementing runnable, what we did, we have first created a new thread, we have first given it a name, we have started it. That is what is being done inside the method or inside the constructor new thread, and within that constructor new thread we have called another constructor of the class thread. Now, and the second method which is being defined here is actually the run method. Within this run method, or this run method we can say, is actually the entry point for the second thread, but we have not written our main function as of now. So, within this main function, or now I can say within this main thread, we need to call this actual our child thread, or this child thread is going to be created or going to be spawned inside this main thread. So, for that we are going to continue this program with another class, which is class thread demo, having public static void main, and then we have created a new thread by calling that class new thread. So, new, then the new thread class, a new thread is being created. Then inside the try catch, similar kind of loop for 5 reversal numbers, and we will be printing the main thread. The main thread will sleep for kind of, let us say 1000 milliseconds, and then interrupted exception E that we are going to catch the main thread interrupted, and then system.out.println main thread exiting. So, what is actually what we have done here? We have actually created one class new thread. Inside that new thread we have created one child thread, we have started it, we have run it, and now within our main thread we have a kind of called that, or we have created a new thread using that, using the constructor of that particular class, in which we have defined run and our method which is the method start. So, that means here inside the main also we have called them, and then we have experimented with main thread. So, output although may vary based upon the specific execution environment, but now here within the program, within this program I am having 2 threads. One is the child thread, which is the demo thread, and another one is the main thread, and both of these threads are kind of printing one particular number, then sleeping for some time, then printing one particular number and sleeping for some time. Now, what is the difference here? The main thread is sleeping for 1000 milliseconds, if you have noticed, while the child's thread is sleeping for only for 500 milliseconds. So, here the output will be like this: main thread 5, child thread 5, child thread 4, main thread 4, child thread 3, and so on and so forth. So, this is going to be the kind of output. I am again repeating that please remember your output may vary in terms of sequences depending upon the specific execution environment, but one thing which is very sure is that the child thread will be exited first, and then at the last your main thread will be exited. So, in a multi-threaded program, it is the main thread which is going to be the last thread to finish running. So, here in this lecture what we have covered is we have seen how to create, first of all we have seen how to take the control of the main thread and run some tweak some of its parameter, for example name and so on and so forth. And then we have seen that by implementing the runnable interface, which is one of the methods of creating a thread, we have create one particular thread and have used it along with the main thread. So, a complete program with 2 of the threads, one is the main thread, another one the child thread, is shown with for the purpose of demonstration. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.